Hi, good evening. Welcome to Ms.STREET Math. So in this video I am going to start a new chapter called lines and angles. In this chapter I am going to explain some basic geometry concept like point, line, ray, line segment and angles. So this basic geometry is going to help you to solve more advanced geometric problems. So I am going to start with a concept called point. Point is nothing but a dot that is put by a pen tip of the pen. If we take a compass, the point is kept by a tip of the pencil. Tip is nothing but a sharp object, a sharp thing of the object like pen, pencil and needle. The examples they are already mentioned. So this is the point concept. Nothing is more needed for this concept. Enough. And second concept is line segment. Line segment has two endpoints. The line segment would not extend. It is fixed by endpoints called A and B. It is also known, it also can be written as line segment AB. And yeah, so this is a line segment of the square, and this is a line segment of something object AB. This is the two endpoints, and the next concept is line. Line has no endpoints and it can be extended without the stopping of them. It extends forever in both the directions, so it does not need any more endpoints. A line can be denoted as L or M. So it has 2 points, but it does not mean it can extend as it want. So it can be written as line AB. Arrow, if we put some arrows in on both side of a line, then the meaning of the arrow is to be it will be extend. If we do not put something arrow in line segment, we didn't put any arrow, so it means it does not extend. In line it will extend, so we keep arrows like this, and the line can be denoted with L or M. And the next concept is ray. Ray is a point, it starts with a dotted point and it will extend until it wants. And there are some examples. Beam of light from a lighthouse. So the light will start at a house, so it is a starting point and it will continue. A light will not stop, right? It will continue the far it wanted to go. So if we wanted to extend, then we will put the arrow. And the light from the torch, it is also so this is starting point and this is ending point, so it does not have any stopping point, so it will extend as it want. And the example of sun rays even. And next we are going to figure it out some questions. With above concept we are going to solve some questions. In first question, Rehan marked the point on a piece of the paper. How many lines can he draw that passes through the point? If we take some point like this in empty paper, we can draw infinite lines. Yes, right? Infinite rays and all have arrows. Arrow is nothing but it will extend as it want. Next, and Seetal marked 2 points on a piece of a paper. How many different lines can she draw that passes through both of them? She can draw only one line. That's the answer. Name the line segment in figure 2.4. Which of the 5 marked points. So these are the points. 5 marked points are on exactly on a line segment, which are on 2 of the line segment. I already told that line segment would not extend, so it has some fixed points which are on the 2 of the line segments, which are on 2 of the line segments. So LM is a line segment, that's right, and MP is a line segment, and PQ is a line segment, and QR is the line segment. So these are the answers. And next, name the rays shown in figure 2.5. Is T the starting point of each of these rays? Yes, ray would start, I already informed that ray will start with a point and it will extend on until it wanted to go. So this is a ray. Yes, is T the starting point of each of these rays? Yes, T is the starting point of all these rays, right? We can also take A as also a starting point because it's a ray, and N is also a starting point of a ray, B is also a starting point of A, but they asked that T is the starting point of these rays. Yes. Draw rough diagram and write label opportunities to illustrate each of the following. Line OP and OQ meet at O. Line OP and OQ, so they meet at point O. So for both P and Q, O is a midpoint, and XY, ray XY and line PQ intersect at, this is known as ray XY, and line PQ intersect at point N. Yes, intersection means a crisscross method across. So ray XY and line PQ intersect at point M. So our line contain points E and F. Okay. And the line is denoted with L, but not point D. Okay, the point D, but not. So we don't need to keep a point on a line. Point P lies on AB. Next sub question D. Point P lies on AB. So they didn't mention whether it is line segment or line or ray. If ray AB or line AB, like this thing mentioned. So if the point P is on line AB, or if the point P is on ray AB, you can write like this. So fifth question, in figure 2.6, 5 points. So here it is point D and point E, point O, point C, point B. These are the 5 points. A line, DB is the line. DB is the line. 4 rays. So from point B, this is one of the ray, and from point O, this is one of the ray, and from point O, this is one of the ray, and another line from point O. So these are the 4 rays 5 line segment. DE is the one line segment, and EO is one line segment, OB is one of the line segment, and OC is another line segment. So here 1, 2, 3, 4, and another one. DB is one of the line segments. So 5 line segments are completed. So with this question is completed. And another question. Here is a ray OA. It starts at point O and passes through a point A. It also passes through point B. Can you also name it as OB? Yes, you can. OB bar is also one of the ray in OA bar, because it is also one of the point in this OA ray. Can we write OA ray as ray O? No, we can't write. A point starts from a, if the ray is something like a point, it starts with a point and it will extend until it want to go. So starting point we have to mention it as O. We can't write it as AO bar. This is the reason. And another concept is an angle. So angle is formed by two rays having a common starting point. Yes, this is a common starting point of two arms. These are known as arms. So you can observe that is also one of ray, and this is also one of ray. So the common point of two rays are known as vertex, and these rays are known to be arm. The point B is called as vertex, and the rays BD and BE are called the arms. I already said for you, right? So for naming purpose, we use it to mention some point on ray. So D, E, and the angle would be here between the two arms, and you can blindly remember that the angle will be at the vertex. So the name is angle DBE. The vertex part should be in middle at every time. You can also write like this, angle EBD, or also angle EBD. So these are the simple technique for angle. And here they mention some pictures. We just want to tell both the arms and the vertex. These two are arms. These two are arms, and this is the vertex. These two are arms and vertex. Arms, vertex. Arms and vertex. Arms and vertex. Two arms are here combined. So this is the vertex. The size of the angle is the amount of the rotation or turn that is needed above the vertex to move from a first ray. If we take two arms like this and the angle was here like this, if we want to extend the angle more, put this arm like this, and we are extending the second arm so that the rotation of the angle will be increased. The amount of turn in the size of angle is more. So this is vertex. Here these are the arms and this is the vertex, and here in scissor these two are arms and vertex. Look at the pictures and mention the angles. So these are the arms and this is the vertex. Arms and vertex. These are the arms and vertex. So here are some of the questions to solve. So the first question, can you find the angle in the given pictures? Draw the rays forming any one of the angle and name the vertex of the angle. So we can find here number of arms. So this is one of two arms, and this is angle, and one more arm and angle, and another one and another one. So these are the angles. I am mentioning it O, A, B, C, D. So we can write this as angle AOB. So this AOB, and another one B, so I'm putting P here, BPC angle. Q, this angle is angle CQD. Yes, so angle AST. So these are the names of vertex and arms, and here are some of. So this is arms and angle ABC, angle ABC. Here there are more number of arms, 1, 2, 3, 4. So these are the vertex A, B, C, D, E, F, G. So angle, so for this angle I am putting ABC, angle ABC, and for this I am putting BCD, for this CDE, for this EFG. That's it. And next, second one, draw and label an angle with arms ST and SR. So ST, so here S is a vertex, ST, and SR. So here this part is vertex and these two are arm. So here the angle, here the angle will be at vertex, right? So this is the angle, so we can tell it as angle STR. And next, explain why angle APC cannot be labeled as angle P. Angle APC, we can't write P, angle P, because P is a point, so we can't write. We have to, if there is an angle, we have to mention angle APC. And that's the right form. We can't write this. And next one, name the angles marked in the given figure. So here one of the angle, so angle QTR, and another angle PTR, and also this is also one of the angle, so angle PTQ. And next, fifth question, mark any 3 points on your paper that are not on same line. So I'm putting dots like this. Label them A, B, C. A, B, C. Draw all possible lines going through pair of these points. Okay. How many lines do you get? Name them. How many angles can you name using ABC? Write them down and mark each them with a curve. So we can get 3 lines. So 3 lines and 3 angles. So here is one of the angle, and this is one of the angle, and this is one of the angle. So angle BAC. So and next this one next ABC, and another one this one. So AC B. So another question. Now mark any 4 points on your paper so that no 3 of them are on line. 1, 2, 3, 4. Label them A, B, C, D. They said that no 3 lines no 3 points are on same line. So I put the dots like this. Draw all possible lines. So 1, 2, 3, 4. These are the possible lines that we can draw. One, two, three, 4, 5, 6, 7, 8. So 8 lines we can draw. How many angles can you name using A, B, C, D? Write them all down and mark each off with the curve as shown in figure 2.9. Okay. So angles, here is one of the angle, and here one of the angle, and this, and also this angle, this angle, this angle, this angle. So here the angles can be also here, and the one of the angle, and this is also one of the angle, and this one of the angle, and this one of the angle. So there are a lot of angles like 1, 2, and this complete thing is also a 3, 4, and 5, 6, 7, 8, 9, 10, and this is also one of the angle. 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 angles. So with this we completed some part of geometry, some basic part of geometry, and comparing angles and something more concept will be said in another video. So please be waiting for another video. Stay tuned. Bye.